So we've spoken about nicotinic acetylcholine receptors. And in nicotinic acetylcholine receptors, we said that, yeah, basically nicotinic receptors are there for acetylcholine to basically bind to and elicit its effect. Okay, so it's good for us to actually know the structure of these nicotinic acetylcholine receptors, right? Basically, how they look like and their components, okay? What they are made of. All right. To discuss the structure of nicotinic acetylcholine receptor, I could see here we have the alpha, we have 2 alpha, 1 beta. Okay, we have a lambda here and this sign. Okay, so let's actually look at the combination of these to actually make up nicotinic receptor. So we said that nicotinic receptors are what? Pentameric structures. When they say something is penta, what do they mean? They mean that that thing has 5 subunits. Okay, so they are pentameric. That means they have what? 5 subunits. All right. So they may consist of alpha units. That's alpha 1 to alpha 10. They could also have beta subunits. It could be beta 1 to beta 4. Okay. They could have this type of subunit, and they could have lambda subunits or what? Epsilon naught subunits. Okay, so these receptors can either be what? Homomeric or heteromeric. Now for homomeric, it means that if it is alpha, then it is only alpha. Do you understand? Then for heteromeric, it means that, okay, alpha can be mixed up with beta, okay, can be mixed up with lambda, can be mixed up with epsilon naught. Do you understand? So nicotinic acetylcholine receptors could be what? Homomeric or heteromeric. So the homomeric receptors contain what? 5 identical subunits, just like I explained. They have 5 binding sites located at the interface between the 2 adjacent subunits. Have what? 5 binding sites, okay, located at the interface between the 2 adjacent subunits. All right. How about the heteromeric now? Heteromeric consists of 5 non-identical subunits. Agonist molecules induce a conformational change that open the channels, while antagonist molecules may bind to the site but do not elicit the conformational change. Right. So antagonist molecules basically bind, they will not activate the molecule, and will even inhibit other activator substances from binding to the molecule. Okay, so on the basis of this, let's just have, I think this is the last slide. This should be the last slide. Okay, second to the last. All right. So the neuronal subunit subtype now. So that neuronal subtypes are made up of various homomeric or heteromeric combinations from 12 different nicotinic receptor subunits. Okay. So if it is alpha, it is alpha 1 to alpha 10. If it is beta, beta 2 to beta 4. Examples of neuronal subunits include, okay, this is neuronal now. Okay, this is alpha 2 to alpha 10, beta 2 to beta 4. Examples of neuronal subtype include what? It could be alpha 4 and beta 2. Okay, combined. It could be alpha 4 and beta 2, alpha 4 subunit 2, beta 2 subunit 3, alpha 4 subunit 3, beta 2 subunit 2. Okay, it could be alpha 7. Okay, so okay, this means that, okay, alpha 4 there are 2 of it, and beta 2 is 3 of it. All right, combining to form the pentameric structure. Okay, then here you could have only alphas, alpha 7, then there are 5 of them forming the word pentameric structure. So let's talk about this alpha 2 in 2 places, and beta 3 into 3, combining to form the pentameric structure. So these heteromeric receptors are found in the central nervous system, and they are made up of 2 alpha 4 subunits and 3 beta 2 subunits, with a binding site at the interface between alpha and adjacent subunits. So now both sites need to be occupied by a nicotinic receptor agonist for channel activation to take place. The alpha 2 beta 2 nicotinic receptors account for what? Approximately 90% of all nicotinic receptors in the human brain. Right? So let's talk about this alpha 7 subunits in 5 places. Alright? And this should definitely be a what? Homomeric receptor. So the alpha 7 receptors are what? Homomeric neuronal acetylcholine receptors consisting of what? 5 alpha 7 subunits. And they have what? 5 acetylcholine binding sites. So abnormality in alpha 7 receptors expression have been reported to influence progression of disease such as what? Alzheimer's disease and schizophrenia. Okay. So guys, that's it about the structure of acetylcholine. Structure of nicotinic acetylcholine receptors, right? Basically talking about the homomeric receptors and the heteromeric. So see you guys in the next one.